Hello, in this video we will talk about a new type of combining functions which is called function composition. We'll start with a little intro activity. So our warm-up, an item originally cost $100. Is it a better deal to apply a $10 coupon followed by a 10% off coupon, or the 10% off followed by the $10 off? So I want you to go ahead and pause the video, do some calculations if you'd like, or just go with your gut reaction, and then unpause and come back for the answer. Okay, so we're back with the answer. So the correct answer should be that we want to do the 10% off followed by the $10 off, and here's why. So let's think about this sort of like an order of operations problem. So option 1 versus option 2. So in option 1, we start with our $100 base price. We take off $10 and we end up with $90. And then we're going to take that $90 and we're going to take off 10% of that. Another way of thinking of that is we're taking 100% and taking away 10%, so we end up with 90%. And if we do 90% of $90, we end up with $81 as our final purchase price. In option 2, we're going to start with the $100 and we're going to immediately take the 10% discount. So we're going to take 90% of, and we end up with $90. And then from that $90, we're going to take off $10 and we end up with an $80 final price. So not a huge difference, but it does look like if we do option 2, do the 10% off, and then follow that up with the $10 off, we get a final price of $80 instead of $81. Now the reason this works is we're starting with a higher base to apply this 10% off. So the 10% is a percentage of, and if we start with a higher base, that will result in a higher discount. Now what we've just done is an example of what's called a function composition. A function composition uses the output from the first function as the input to the second function. So if we're thinking about this particular warm-up problem, we are creating kind of one function that is composed of two functions. If I look over here at option 1, perhaps you can see that the final price here, if we think of x as our original price, the final price here was found by taking the original price, subtracting $10, and then multiplying that result by 0.90. And I want to think of the first function as the x minus 10, and then the second function is taking the 0.90 off of that. So let's call this like price 1 of x. Now if we look over here at option 2, maybe you can see this function as first taking the 90% of x, and then after that subtracting the $10, and we could call this p sub 2 of x. So I tried to color code kind of what happened first versus what happened second. I'm thinking of the subtracting 10 as this red function here, which would be over here the red function, and taking the 90% of as the blue function. Now we'll get more symbolic examples later, so I just want to talk a little bit about the notation. So the notation we use for function notation, we use this little open circle here, which means function composition. So I would read this as f of g of x, or f of g of x in function notation. Just to reiterate, function composition uses the output from the first function as the input to the second function. And on the next slide, I show you a little visual representation of what that means. Function composition, I want you to think of having two functions. And we're going to call these two functions, let's call them f and g. If I say I'm doing f composed with g of x, the first thing you need to understand is that this circle means composed with. We always want to think about translating that into function composition notation, which really, this is just function notation, writing it so that you can see which function is on the outside and which function is on the inside. So whatever the inside function is, that's the function that you do first. And then the outside function is what you do second. So I want you to think about a function machine, and the function that we're doing first in this particular example is we're doing g. So we take an x value. Let's say I take an x value of 3, and let's say that the g of x function is the function that just doubles. So if I take g of x equals 2 of x and I give it 3, then my output would be called 6. Now I'm immediately going to turn around and I'm going to take that output and I'm going to put it into a new function, f. And let's say, for example, that the f function is the function that takes the x value and it adds 5 to it. But the x value that I'm taking in to f is I'm taking 6. So when I look at this rule for f of x, I'm going to take 6, whatever my x value was, and add 5 to it, and what comes out is 11. But notice the x value that I originally put in was actually 3. So I didn't just take 3 and add 5 to it, as the function says. I first took 3 and I doubled it to become 6, and then I took this output, so the output of g of x, becomes the input to f of x. That's what function composition is you're taking an output from one function and making it the input to another function. So stay tuned for the next video to see some more examples with some particular functions.